All right, let's talk AI. It can feel like this total black box, right? Some kind of crazy complex magic. But what if I told you the secret to the whole thing wasn't some high-tech secret, but was actually hiding in your old high school math notebook? Seriously, let's crack it open and see what's inside. No, I'm being completely serious. Just think about that for a second. What if the stuff that powers everything, we're talking ChatGPT, self-driving cars, all of it, is built on the exact same rules you learned in like ninth grade algebra? So that's what we're going to do today. We're going to pull back that curtain and show you that AI, it's not magic. It's just math. I mean, it's a massive, incredible amount of math, sure, but it's built from the simplest pieces you can imagine, just scaled up to a point where, yeah, it feels like magic. Okay, so where do we start? Well, our journey begins with the most basic thing of all, multiplication. And trust me, it's way more than just a simple calculation. It's really the first spark of intelligence. Take a look at this. On one side, you've got a math problem a kid could solve. On the other, that's the core of a neural network, and it's basically the same thing. In AI, you take an input, some piece of data, and you multiply it by a weight. That's it. And then you just do that billions and billions of times. The entire foundation of AI is just a mountain of multiplication and addition. So here's the key idea, the big shift in thinking we need to make. Multiplication isn't just about getting an answer, it's an interaction. You have two different pieces of information, the weight and the input, and when they come together, they create something new, something more meaningful. And that, right there, is building block number one. Okay, so we've got interaction. That's great. But how on earth does an AI keep track of millions or even billions of these things? How does it organize it all? Well, the answer is kind of crazy. It comes from parentheses. Yeah, those little curved lines from math class. You remember the order of operations, right? You always solve what's inside the parentheses first? Well, guess what? A neural network does the exact same thing. It groups its calculations into layers, and each layer is basically just a giant set of parentheses in one enormous nested math equation. And this shows you exactly how it flows. The AI crunches all the numbers in one layer. That's the stuff inside the first set of parentheses. Then it takes that result and feeds it to the next layer, which does its own thing. This creates a really clear order, a hierarchy for how everything gets calculated. And that is what we mean by structured computation. It's how an AI seems to think in a logical, step-by-step way. See, it's not just a chaotic soup of numbers flying around. It's an incredibly orderly process, and it's all thanks to the simple idea of grouping things with parentheses. All right, let's step it up a notch. We've got interaction from multiplication, and we've got structure from grouping. So what's next? Well, the next two pieces, scaling and powers, are what give AI its real smarts, its ability to actually learn. So in math, when you multiply something by a number, let's say 3, you're scaling it. You're making it bigger or smaller. In the world of AI, this is a huge deal. That number you multiply by is called a weight, and it's basically how the AI decides how important one piece of information is compared to another. It's simple, really. A big weight means pay a lot of attention to this. A small weight means, this isn't so important. And here's the cool part. The AI figures out the perfect weights all on its own. That's what we call training. It's literally learning what matters. Okay, now for powers, like squaring a number or cubing it. This might sound a little abstract, but stick with me, because this is the key that unlocks AI's true potential. Using powers lets an AI see and understand complex, curvy, messy patterns, not just simple straight lines. The fancy term for this is non-linearity. And without it, AI would be pretty dumb. It could only solve super basic problems, but with it, suddenly it can recognize faces, understand human language, and make sense of the tangled up patterns of the real world. I mean, this is a massive leap forward. So let's recap. We have millions of interactions. They're neatly organized into layers, and each one has its importance carefully weighted. But with all this going on, how do you stop the whole system from just, exploding, from spiraling out of control? You need balance. And this is where the humble square root comes into play. In math, a square root is a way of finding a kind of balance, a mean. And in AI, we use this exact idea for something called normalization. It's a trick to keep all the numbers flying around inside the network in a nice, stable, manageable zone. You can think of it like a governor on an engine, you know? It stops the calculations from either getting ridiculously huge or shrinking down to basically zero while the AI is trying to learn. And that stability, it's absolutely non-negotiable. You literally can't train the giant AI models we have today without it.
Okay, let's put it all together. What have we seen? We've seen that all these simple math ideas aren't just like what AI does. They're not just metaphors. They are the literal, direct building blocks of artificial intelligence. So if you wanted the recipe for AI, what is it? Well, it's these 5 things. You multiply to create times interaction, you group to create structure, you scale to decide importance, you use repetition and powers to understand complexity, and you use roots to find balance and stability. That's it. That is the whole recipe. This right here, this is basically the ultimate cheat sheet. It lays it all out, a direct one-to-one connection. Every single core idea in a cutting-edge neural network maps directly back to the basic algebra you learned in school. It's the same logic, the same structure. It's just happening on a scale that's almost impossible to wrap your head around. And really, this is the big takeaway. This is the whole point. AI isn't some mysterious, unknowable magic. It's just multiplication, addition, grouping, repetition, and scaling applied millions and now billions of times. You just repeat these simple rules over and over until something that looks and acts intelligent just emerges from the complexity. So I'll leave you with a final thought. If something this incredibly powerful can be built from such simple, almost childishly easy rules, what does that actually tell us about the nature of intelligence itself? And what does it mean for what we'll be able to build next? Something to think about. Thanks for joining me.